All right, guys, 11.7, looking at cones here, looking at volume and surface area of cones. You see some vocab, and we've talked about height before, and I've mentioned it before, but we have this new idea of slant height. And slant height is the distance between the vertex down to the base along the edge of a cone or a pyramid. Would be the slant height. So you're going to see that in here. Just make sure you remember the difference between slant height and actual height. They're represented by different letters. Slant height is represented by an L for some reason. Maybe because there's an L in slant, I don't know. But L for slant height, you'll see. Talking about the lateral surface. Lateral surface would be anything, all the segments that connect the vertex with points on the base edge. So your lateral surface is basically everything that's not the base. So it would be the area around the figure, right? It's the wrapping. It's not the base, it's everything else. That's talking about the lateral surface of it, okay? So they're going to show us how to get there. We don't need to know all of this. What we need to know is this core concept here, which is just the formula. All right, you got the surface area, capital S, surface area, is pi r squared. That's the base, right? Pi r squared is the base. That's the circle at the bottom. And then pi rl. Pi rl is going to give us the lateral area. Okay, it's the area of that curved portion that's gone around the base, is that pi rl. So if we want to find the surface area of the cone, we've got pi rl, which is that lateral, and then we add on the base. That bottom is still surface area, so that's the pi r squared. So if we use both of those, we can find the surface area. Surface area, remember, is anything that touches the air is considered surface area, or like I like to talk about, I like to think about it. If you were to take the figure and dunk it into a bathtub or into a bucket of water, right? Whatever gets wet, that's surface area, right? Because that's on the outside. So you can't forget about the base. You can't forget about the bottom. Sometimes people do. But that would get wet if you dunked it in a bucket of water. Okay, so you've got your formula that we got to use. Pi r squared plus pi rl. Just make sure you are using slant height and not regular height for that L. So the surface area, you got your radius of 4, your slant height of 6. We can plug it right in the formula. You see it there, about 40 pi, or if we plug it in. So they're going to do that. They're also going to ask us about volume. And volume is, again, very close to, well, it's the exact same as what we did for a pyramid, right? A pyramid, we said, was 1/3 base area times height. It's going to be the same thing. Only now we know that the base is a circle. So the base is pi r squared. So they get a little more specific about it, right? You see the 1/3 base area times height. And then they just get a little more specific because we know that that base has to be a circle. So that's where the pi r squared comes in instead of the base area. So it's the same exact thing that we dealt with the pyramids. So we should be good there. Just again, this uses h, the actual height, the perpendicular height. So if it's slanted, right? If it's slanted, which is what we see on the right picture here, where this one's straight up and down, perpendicular, so we can use that as the height. If it's slanted, then the height has to be perpendicular there, right? So we got to be careful on that. So we should be able to do those. Again, the hardest part there is just knowing the difference between slant height and regular height. Sometimes you might have to use Pythagorean theorem, right? 5, 8, and then h for your height, and be able to solve it that way. Then we get into finding the volume of a similar solid. This is what we did the last couple sections still. Remember, you have to cube the scale factor. If you cube the scale factor, then you can set up the proportion to be able to solve for the volume. So in this case, my scale factor is 3/1. I would cube that. I would get 27 over 1 is equal to x over 15 pi, and then be able to solve it. They set it up slightly different. It's the same idea. I just have a 1 under that 3 cubed. So we've got that, and then we've got composite figures where you just got to find the volume of two different things, put them together. They don't really ask surface area of composite figures, just volume. So that's a good thing. We don't have to worry about what's covered up and what's not. We're just worrying about the volume there. Okay, and that's really all that we have for 11.7.